Hey, Algebra 2 kids, sorry I can't be there with you today. We are going to start by having a review of rational functions, which is something you have done in Algebra 1 and at the beginning of this year actually as well. So Algebra 1 you saw this, and Algebra 2 the first semester you saw this. First couple of problems, as we fill them out, you just have to remember the rules. For part A, a couple different rules happening here, or you can just write it out the long way. If I were to write this out the long way, I would have 24A, A, 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 A. That's a to the fifth, and then B squared. Over 2AB, I'm going to write that 4 times. That's what that little 4 there means. So 2AB, 2AB. And then remember, you can start canceling things out. You can have, let's see, it's going to be 24 on the top. That's going to cancel with 2 times 2 times 2 times 2, which is 16. We'll simplify that in a minute. We're going to have an A cancel out, a B cancel out. And, I mean, this is the old-fashioned way from Algebra 1 to do this problem. Some of you are still going to want to think of it like this, though. This B has nothing to cancel out with, this B as well, and then an A. This is actually, I don't know. Now that I know the tricks, sometimes this way kind of confuses me. I've got an A on the top and a B squared on the bottom. And then we can simplify 24/16. Take a 4 out of, actually take an 8 out of both of them, and you're left with 3A over 2B squared. All right, now let me show you how to do this problem using the quote-unquote tricks. You'll remember we learned first semester that a power to a power you multiply. So on the bottom in the denominator we have a to the first, ignore the numerator for a minute. We have a to the first, b to the first, to the fourth. What you can do, you're not distributing the 4, but it kind of works that way where each different part of the monomial can be taken to the 4th power. So you would have in the denominator 2 to the 4th, which we found was 2 times 2 times 2, which was 16. A to the first to the 4th, so A to the 4th, and what you are doing is you're taking the 1 and the 4 and you're multiplying them. This would be more exciting if we had anything other than a 1, A to the first, but regardless. And then B to the 4th as well, because again we are multiplying. Okay, can you hear Riley, my daughter, in the background? Yeah. Anyway, she's going outside to look at the moon with her dad through the telescope. Okay, then we have the numerator. What you can do now, again using the quote-unquote tricks, is you can look at the A's. Think about how many of them would cancel. Well, since there's 4 on the bottom, 4 of them would cancel, leaving 1A on the top. By the way, we would still have 24 over 16, which that's a fraction that we reduced. And then you can think about the B squared and the B to the 4th, and how would those cancel? What you're doing is you're subtracting the exponents. So for the A's, it was 5 minus 4 is 1. And for this one, 2 minus 4 is negative 2. So negative 2, if you remember, a negative exponent is on the bottom of the fraction. We called it being downstairs. Regardless, if you thought about how they simplified b squared over b to the 4th, you would be left with b squared on the bottom. So the answer would be the same, simplifying that, taking an 8 out of it to make it 3 halves. So 3a over 2b squared is the answer, either way you do it. All right, the rest of these examples should go a little bit more quickly because they don't have as much to talk about. Part B, remember when multiplying fractions, you multiply straight across. You also can go through and simplify things that you see instead of multiplying straight across first. You can simplify, so for instance, ooh, that's really blurry, I apologize. I would probably simplify, if I were doing this problem, the 3 and the 9 right away, leaving just a 3 for myself here, and the 20 and the 5, leaving just a 4. Also, my R's I see are going to simplify. These are going to completely cancel out, leaving just 1 on the bottom here. My S's will cancel, leaving an S squared, and my T's will cancel, so I'll have T squared on the bottom. When I multiply these across, I'm going to have 4S squared over 3 T squared R. Doesn't matter which order you put the T in the R. If you want to do it in alphabetical order, 3RT squared, that's fine as well. We also could have gone through and multiplied everything out and gotten 60R squared S cubed T squared over 45T to the 4th R cubed S. Written it out long ways like I did part A and simplified, and you would still get the same answer as that. Yay! All right, so to conclude the first part of this little lesson, the practice problems down here I want you to do, I'm going to put up the answers right now for you. I'm not really going to give you an explanation, but don't be lazy. Write out number 1 the long ways if you need to, and remember to multiply. Number 2 straight across. Number 2 has a cute little trick. Think about the 3 M's canceling. So, yep, the next thing you'll see is the answers. So pause this right now if you're not ready for the answers. Pause now. Actually, on second thought, I'm going to do practice problem number 2 in the second video. I think it fits there better. So wait on this one. Thanks.